Okay, guys, this is exam 4, problem number 5. Let A equal the set containing all integers n such that n is equal to 5r for some integer r, and B is equal to the set containing all m's that are integers such that m is equal to 20 times s for some integer s. Part A is asking, is A a proper subset of B? So the first thing I'm going to do is I'm going to select just um, another variable that's not in my definitions. And I'm going to claim that it's P is equal to 5. I'm starting with A, so I need to start with the definition of A. P is equal to 5R. Nothing really I can do with that, but I'm just writing a note to myself. Actually, I should have said aside. I'm sorry. I'll put aside first. So P is equal to 5R, where R and P are both integers. All right. Now I'm starting with 5R, and I want to go to the form 20s. So what I'm going to try to do is I'm going to try to factor out a 20. I know it's going to fail, but let's do it anyway. I'm going to factor out a 20 out of the left-hand side. So that's 20. So that is 1/4 R, right? And notice how 1/4 R is not an integer. And so because it's not an integer, that means this is false. So now let's find a counterexample. I'm going to start by saying R equal to 1. So I don't know if that'll work. I'm just starting at an easy place. So R equals 1. So that means that P is equal to 5 times 1, which is 5. Now I'm going to set 20s equal to 5. And then solve for s. S is equal to 1/4, which is not an integer. So 5 is my counterexample. Okay. So now for my explanation, I'll say that it's false. Let n equal 5. 5 is an element of A because 5R equals 5 has integer solution R equals 1. However, um, 5 is, sorry, I messed up a little bit. I should have said n here. N is an element. N is not an element of B because 20s equals 5 has no integer solution S. Thus, A is not a proper subset of B. Okay? And so the second part of the problem is just switching the order. We're now asking if B is a proper subset of A. All right. So again, I start with my aside. I claim that P is equal to 20s, where P and S are both integers. I'm starting with 20s, and I want my form at the end to look like 5r. So I will factor out a 5. So that's 5 times 4s, which is equal to 5r, where r equals 4s is some integer. So what I'm claiming here is that every b is an a. That's what this proves. Okay? I mean, I haven't gotten to the proof part yet. Don't forget that the definition of a proper subset isn't just if every b is an a. A proper subset, written like so, every b is an a, but a contains elements not found in b. Well, we've already proven that above. Right? We've already proven that a has elements not found in b. So I'm going to use the same sort of workup. All right? So now let's get to our proof. Let P equal 20s be an arbitrary but distinct element of set B. Therefore, P equals 20s, which is equal to 5 times 4s, which is equal to 5 times r, where r equals 4s is some integer. We can conclude that every element P in B is also an element of A. Let n equal 5. N is an element of set A because what is it? 5r equals n has integer solution r equal 1. However, n is not an element of B because 20s equals n has no integer solution s. Since all elements in B are also in A, and there exists an element in A that is not in B, we can conclude that B is a proper subset of A. QED. We're done. And just as a note, this is a little bit more rigorous than he was probably asking for on the test, but this is how I did the problem. And I figure if you guys can do it the hard way, then if he's not asking for a formal proof, then it should be easier.